Welcome to The Explainer. Today, we're going to tackle a really interesting and, frankly, tricky bug, Plesiomonas shigelloides. It's a fascinating organism that sits right at the crossroads of classic microbiology and modern molecular diagnostics, and it's one that every single clinical lab needs to be ready for. Now, everything we're about to cover has been synthesized from a deep dive into the current literature. And hey, if you're the kind of person who loves to dig into the primary data, you can access every single source in the linked notebook document. So, here's how we're going to break it down. We'll frame this whole thing as a diagnostic challenge, starting with its really unique taxonomic puzzle. Then we'll walk right through the lab identification path, look at its clinical impact, talk treatment, and finally, wrap up with prevention and control. All right, let's kick things off with a question that gets right to the heart of the matter. This single question is the absolute key to understanding Plesiomonas shigelloides and why it can be such a headache in the lab. You might be thinking, taxonomy? Really? But trust me, understanding its family tree isn't just some academic exercise. It's fundamental to why we identify it the way we do, and honestly, why it gets missed so often. So, its history is pretty wild. For years, it was lumped in with the Vibrio ACA, which makes sense, right? It's oxidase-positive and lives in the water. But then, molecular methods came along and, whoa, everything changed. Based on 16S rRNA sequencing and the fact it has the Enterobacterial common antigen, it got moved firmly into the Enterobacteriaceae. This dual identity is what we have to grapple with. Okay, so with that whole identity crisis in mind, let's get practical. Let's head to the bench. How do we actually navigate this organism's dual personality when it shows up on a plate? On our standard enteric media, this thing is a master of disguise. On MacConkey, it's just another non-lactose fermenter. On XLD or SS Auger, man, it's a dead ringer for Shigella. This is where the trouble starts, because it looks exactly like a common enteric pathogen, but it's not. And this, right here, is the absolute most critical point. I cannot stress this enough. For any non-lactose fermenter coming from a stool culture, the oxidase test is non-negotiable. It is the single most important step. If you skip it, you are going to misidentify this organism completely. It's the key that unlocks the entire puzzle. Now, once you're on the right track, thanks to that oxidase test, check this out. The biochemical profile is beautiful. Look at that, a triple positive for lysine, ornithine, and arginine decarboxylases. Combine that with its ability to ferment inositol, and you've got a highly characteristic pattern that separates it cleanly from all the usual suspects. Of course, now we have to talk about the new kid on the block, molecular panels. These CIDs are a real game changer. We're detecting Plesiomonas shigelloides way more often. But, and this is a big but, we get a positive signal, a piece of data, but we don't get an actual bug on a plate. This creates a real dilemma. We know it's there, but we can't do susceptibility testing, which really complicates things for the clinicians. So we've wrestled it down in the lab. We've got an idea. But why? Why does all this careful work matter so much? Let's connect the dots from the bench to the bedside and see what this means for the patient. For the most part, you're looking at gastroenteritis, usually from contaminated water or seafood. But it's those less common extraintestinal infections where the stakes get incredibly high really, really fast. And when I say high stakes, I mean life-threatening. In vulnerable people, the immunocompromised, patients with liver disease, and especially in newborns, this organism can cause devastating invasive disease. We're talking bacteremia, and particularly neonatal meningitis, which can be just catastrophic. And get this, here's an emerging idea that's really interesting, the co-infection hypothesis. Some of the latest evidence suggests that Plesiomonas shigelloides might not always be the main villain. It might act as a powerful accomplice. When it teams up with another bug, like a rotavirus, it seems to dramatically increase the severity of the diarrhea. Okay, so now we know what it is and what it can do. How do we fight it? Let's open up the clinical playbook. This is where the lab's work directly informs what happens on the wards, especially when it comes to the nuances of susceptibility testing. Now, while there aren't any species-specific guidelines from groups like the Dutch Working Party on Antibiotic Policy, a clear consensus does emerge when you look at the international recommendations. For severe gastroenteritis in an adult, the first choice is a fluoroquinolone, like ciprofloxacin. Trimethoprim sulfamethoxazole is often the second choice, but that depends a lot on local resistance. Okay, everybody listen up, because this is a huge take-home point. The standard empiric regimen for neonatal sepsis, ampicillin and gentamicin, is completely inadequate for Plesiomonas shigelloides. Why? Because it's intrinsically resistant to ampicillin. If this bug is even on the radar for a neonate, cefotaxime is the drug of choice. This is the kind of critical info that requires a phone call from the lab to the clinical team. This table just lays it all out nicely for you. You can see the whole spectrum of treatment, from a short course of oral Cipro for an adult with bad gastroenteritis, all the way to a long, high-dose IV course of cefotaxime for a baby with meningitis. And of course, the golden rule always applies. This all has to be confirmed with definitive susceptibility testing. This quote from EUCAST is essential. Because of that intrinsic resistance we just talked about, you have to always report ampicillin as resistant. It doesn't matter what your instrument says or what the raw breakpoint interpretation is. If you report it as susceptible, you're making a serious laboratory error that could lead to treatment failure. So when you put it all together, the resistance profile is actually pretty predictable. Penicillins are out, always resistant, but it's generally susceptible to third-gen cephalosporins and fluoroquinolones. Carbapenems are also highly active. The one to really watch is trimethoprim sulfamethoxazole, which can be variable, so you absolutely need to check your local antibiogram before using it. Finally, let's talk about how we break the chain. How do we stop this bug from spreading, both out in the community and right inside our own labs? And it really all boils down to the basics, doesn't it? It's about fundamental public health and lab safety. Rigorous hand hygiene, especially after you've been messing with your fish tank or handling animals. It's about food and water safety, avoiding raw seafood and making sure drinking water is treated. And for us in the lab, it's strict biosafety level 2 practices, end of story. So I'll leave you with this final thought to chew on as the research continues to evolve. Is Plesiomonas shigelloides truly a primary pathogen in most cases of diarrhea? Or is its main role to act as a powerful accomplice, making other infections way, way worse? And that wraps up our deep dive into the complex world of Plesiomonas shigelloides. For more specialist explainers just like this one, please do us a favor and subscribe to the channel. We honestly value your expert feedback and insights, so please share your thoughts and experiences in the comments below.